Hello everyone, welcome back to the channel. Welcome back to another video in our data structure algorithm series. The topic that we are discussing right now is linked list. And in last video was very interesting where we understood how do you remove the node from the end of the linked list. For that we did multiple things, right? For that first we checked if the list is empty or not. Then we checked for the scenario where you had only single node in the linked list. And then for when you have more than one node in the linked list, you were able to find what is the previous node through this logic of iteration, right? And then you are able to remove the last node, right? So as part of this video we are going to understand how do you remove a node from the beginning of the linked list, right? Now removing the node from the beginning of the linked list is very easy as compared to removing the node from the end of the linked list, because the iteration that you did to find the previous node and all, right, that is not actually required. Let me show you that with the implementation itself. So let's implement that method. Public int remove first. Yeah, that's correct. Now what do you do for the first time? Now I'm going to copy some code so that I don't have to code it again, right? So there is a chance that your list is empty, right? So in that case we are going to throw the same exception. There is a chance that you have a single node in your linked list, right? So these two scenarios are actually common, right? Even when you want to remove the first node in the linked list, right? So we literally copied that code. Actually you can make this particular piece of code as a separate method and then you can call that method here, but just for simplicity, right, so that we can understand what we are doing in that particular method, I'm keeping it here only, right? I'm not extracting out this part of code where we are checking when you have a single node in the linked list, right? So these two scenarios we copied, right? When you have when you have empty list and when we have a single node, right? Now you need to get hold of a second node in the linked list. How do you do that? Let's create a temp node. Now what does this temp node should hold, right? It should hold head dot next. That means the second node of our linked list, right? Now what you do? Now you know that the second node is being held by this temp node, right? Head dot next is equal to null, right? So the moment you do this head dot next is equal to null, right, the link between your first node and second node is cut. Now your second node is only being held by this temp node, right? Now what you should do, you're supposed to make sure your head points to your second node, which is this temp node, right? For that what you do, you change the pointer of head to point to this temp node, right? Now it's very clear. Let's reduce the size, minus. So before we set this value of head to temp node, right, we are supposed to hold the value of the head node itself, because head node is the first node and that is the value that we are removing. Okay, so we know that we are returning the value of the node that we are removing, right? So as you know that this is always going to be the first node, and we know the head is the first node, right? And we already copied this part of code also from the last method, right, which is removed element is going to head that value. So all we are supposed to do, we can just straightforward return that removed element here, and that's it. Now let me summarize this method for you. So first you are checking if your list is empty, you're throwing an exception telling the list is empty. Then you're checking if your list has only one node, right? Then what you're doing, reducing the size to 0 and making the list as null, returning the head element value. If you have more than one element, right, then you're setting the second node to the temp node, right? Now your second node points to this temp node. Your head dot next, that means the link between the first node and the second node, you're setting to null. Now head no more points to the second node, right? And the moment you change this head to a temp node, right, the first node of the linked list becomes eligible for garbage collection because there is no pointer pointing to the first node, right? And you reduce the size and return the removed element, basically. That's it. So you see, removing the node from the beginning of the linked list was easier than removing the node from the end of the linked list. And this is an O of 1 operation, that is a constant time complexity. How constant? Because all you're doing when you have single node or multiple nodes in the linked list, right? All you're doing, you're just changing your head pointer, that's it. You're manipulating the head pointer, that's it. You're not iterating through the list or any sort of iteration. You just manipulated the head pointer, reduce the size, that's it. That's why it's a constant operation that you're performing only once, right? And that's how your remove first method is implemented. Now let's see again if this implementation is correct or not, right? How do you do that? Let me check for now what is the element we have removed. If with this particular input, right, I think 30 is supposed to be removed. Yeah, so 30 is removed. Now as part of this insertion, right, 40 should be the first node. Now if we try to remove that as out list dot remove first, it should return 40. So yeah, it is returning 40. That means our implementation is perfect, right? I hope this is very clear, right? We are reducing the size and increasing the size when we were adding and removing the node, right? But we haven't actually implemented a method for it. So in our next video, we will be implementing the method size method, which will straightforward tell us the size of the method. Now we could have done that in a linear time complexity as well, that is O of n. But I'll show you how to do that in constant time, right? Actually, we are already doing it. I'll just show you why we did in such a way so that you can calculate the size in constant time complexity. Let's see you in the next video. Meanwhile, may the source be with you. See you in the next video.